Section 1.5 is measuring and constructing angles. An angle is a set of points consisting of rays that have the same endpoint called a vertex. You can name an angle by its vertex by using a point on each ray and the vertex and using a number. So a couple things before we get started there. Remember, if it's on the inside, this will be important for us. So we have the interior of the angle, all right, which I just put here in red, and we have the exterior of the angle, which I have here in blue. So just like we did before, people, what you need to realize is that those rays are going to extend forever, so we'll always have an interior there. We will need to know that here soon. So if we name an angle by its vertex, on this one that we're looking at right now, our vertex is right there, all right? Here's our rays, AC, here's our rays, AB. So on the first one, it says by its vertex. So on this one here, we're going to call it angle A. And I put a little dash in there, arc, because everybody tells me my L's look like A's. So right there, that should tell you it's angle A, all right? Our second one, it says by using a point on each ray and the vertex. It's important that the vertex be in the middle of it. So I can either go this way here. If I go this way here, I'm going to call it angle CAB. And if I go the opposite direction, so if I go this way right here, I could call it angle BAC. So I can call it by either of those, all right? And then finally, sometimes I even suggest that if you're not sure, you can always put a number in the angle there, especially if you're writing proofs. So the last one there, we could call it the angle 1. Okay? Now, when a point is a vertex of more than one angle, you cannot use the vertex alone to name the angle. So let's go ahead and see what they're talking about there real quick. So here's my one that we have up above. So I'm again going to call it CAB. But it's saying now that I have another one here. All right? Let's call this angle D. Point D. So on this one right here, we can't call it angle A. Because again, I wouldn't know which A you were talking about. Are you talking about this one right here? Or are you talking about this one here, which we used earlier? Again, both of them have the vertex as an A, but again, since there's two of them, I cannot use angle A. I can't call it angle A. Okay, so our first example here, write 3 names for the angle. So based on what we just said, we could call this by its vertex. We could call it angle U. We could call it by its 3 points. So we could go that way. We could call it angle VUT. Or again, we could go the opposite direction. We could call it angle TUV. And again, we could also call it by its number. In this case, it would be angle 3. All right? So you can classify angles according to their measures. So remember, if it's cute, think of it as, oh, what a cute little angle. All right? That tells its measures between 0 and 90 degrees. Okay? it can't be exactly 90 degrees. If it was exactly 90 degrees, you'd have a little box there that I just kind of filled in there. And that means it's exactly 90 degrees. So a right angle is always 90 degrees. And an obtuse angle, now think of it as a fat angle. Obtuse also means fat. So this one here is going to be between zero, so it's going to measure greater than 90 degrees. And less than 180 degrees. All right. So 180 degrees would be this one right here. Okay, that would measure 180 degrees. It's a straight line, but we also call it a straight angle. So a straight angle measures 180 degrees. And those are 4 types of angles that we can have. All right. So just like we had a segment addition postulate, we have an angle addition postulate. So remember, on the angle addition postulate, the parts still equal the whole. So what they're trying to show you on this one here, now it doesn't show you very well right here. I mean, it does on this one here, but on yours, it'll look like it's black and white. So it won't be as well. So a lot of times, you can also mark an angle by putting an arc in it, a tick mark in it. So there I have one, and it's actually red on this, but on your paper, they'll both be black, so it kind of looks the same. But on this one here, if I put 2 tick marks, angle PST is different than angle RSP. The M stands for the measure. So what it's telling us is that the sum, the parts, so again, RSP plus PST is equal to the whole, which is RST. Okay? And that's what you have to remember on that. Let's look at some examples using this stuff. So example 4, given that the measure of, so this M in front always means measure. So given that the measure of PQR is equal to 102 degrees, find the measure of angle PQS and the measure of angle SQR. So by our segment addition postulate that we just saw previous, we can say that the measure of angle PQS plus the measure of angle SQR is equal to the measure of angle is equal to the measure of angle PQR. And again, let me fix that because it says the measure, so we're going to be using numbers. All right, so if we look at this, we can say that PQS, 7x minus 5 degrees plus our other part, 9x plus 11 degrees, is equal to 102 degrees. All right, so let's just go ahead and combine our like terms. Since it's all on one side, we can say it's 16x. And then we have negative 5 plus 11, which would be plus 6, is equal to 102. I'll subtract 6 on both sides. So I'll get 16x is equal to 96. Now I'm going to divide by 16. That'll give me that x is equal to 6. So now to find the other two, I'm going to plug it in. So the measure of angle PQS is equal to 7 we said x is 6 minus 5, which will give us 37 degrees. And then the measure of angle SQR is equal to 9 times, again, our x was 6 plus 11, and that'll be 65 degrees. And then why don't we say, as a check, because, you know, I always tell you, you can always check your answer. Does 37 plus 65 equal 102? Well, yes, it does. So it checks. Okay. Now, if the angles are the same, so on this one here, it says an angle bisector is an array that divides an angle into two angles that are congruent. So if we look at it here again, since it's black and white on yours, it is showing you that this one here and this one here are the same. I put tick marks on there to show you. So we know that YW, now YW, the ray, is on the interior of the angle. So again, we know that it cuts it. We just need to know if it bisects it. Well, since I told you by the tick marks that it is, we can say that the angles are congruent. So angle XYW is congruent to angle ZYW, and their measures are equal. So we can say that the measure of angle XYW is equal to the measure of angle ZYW. Okay? So let's see here. Example 5. VB bisects angle AVC, and we know that the measure of angle AVC is equal to 158. Find the measure of angle BVC. So on this one here, you know, ladies and gentlemen, that it bisects it. First of all, we know that it's an obtuse angle, so let's just go ahead and draw an obtuse angle here. It doesn't have to be perfect, we just have to make it look fat so that it does exactly what it says. Now it's telling us that VB, so we have VB here, and we know that it bisects angle AVC. All right? So it says to find the measure of angle BVC. So we're going to find this angle right here. But we know that that angle and that angle are the same length. All right? So let's start with what we know. We know that the measure of angle AVC is equal to 158 degrees. We know, since it bisects it, we know that the measure of angle BVC is equal to 1/2 the measure of angle AVC. So that would mean it's 1/2 of 158 degrees. So we know that the measure of angle BVC is 158 divided by 2, or 79 degrees. All right, so that's one when they don't give you a picture, you can draw a picture, real simple. And then just like we did last time, I mean with example 4, now we're going to do some algebra with it. All right. So on this one right here, we know that angle line segment, let's go one more time. Ray QR, so ray QR bisects angle PQS. Since it bisects it, we know that this one here and this one here are equal. All right? Since we know they are equal, ladies and gentlemen, we can say that, and here I'll even mark them as equal for you. We can say that 4x minus 10 is equal to negative 3x plus 130. All right, I'm going to add 3x to both sides. So that'll give us 7x minus 10 is equal to 130. I'm going to add 10 to both sides of the equal sign. That'll give me 7x is equal to 140. And now I'm going to divide by 7. So when I divide by 7, 140 divided by 7 is 20. All right? So since that is the case, again, read the directions carefully. Is it asking us to find x? No, it's asking us to find the measure of PQR and the measure of PQS. So we can start with the measure of PQR. And we know it's going to be 4 times, 20, right? Minus 10. So 4 times 20 minus 10, that'll equal 70. And the measure of angle RQS is equal to negative 3 times 20 plus 130. And if we plug that in, negative 3 times 20 is negative 60. 130 minus 60 will also give us 70. And again, we should put, well, I'm pretty sure that when you do it in the online textbook, it'll do it for you as the degrees. But again, as a check there, does that equal 140? And again, there I keep forgetting. And it does equal a quick check, all right? So this is the one we needed, and we needed PQR. So these are the two that we needed, all right? So same kind of idea on the homework, ladies and gentlemen. Thank you.